Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and today we're doing this live stream, another late night live stream, where we're going to be completing the assembly on the LED lighting controller. We started this last time in the last video, or in the last live stream. So if you want to check that out, be sure to click here. That'll be there if it's after the fact as far as a VOD. But if you're here live, stay live. It'll be a lot of fun, and I think it'll be self-explanatory where we're at. So jumping right into it, so this is kind of where I've gotten to. I've done a little bit of work since we've been, since the last live stream, to try and refine this a little bit, and I have gotten it a little bit further. I figured out the issue that was relating to why it kept erroring last time, and that was relating to an issue with the explicit string declaration for the content type. And what that meant is that it didn't actually know how to interpret the individual characters that were coming in from the web request. So that's why I kept erroring out. And there's still quite a bit to go in terms of the programming. But I've gotten all of the circuitry put together. So it has the two drivers here. And you notice it's kind of a mess in terms of the wiring, everything else like that. But I did actually cut and prepare this case as well. So if we get the programming all settled, we'll be able to actually just do the final assembly and see it all once it's done. But what these are the MOSFET drivers, which are pretty much converting the low voltage of the Raspberry Pi Pico, that is the output of the pins, which is 3.3 volts. Those are triggering these MOSFETs, which are converting it to a higher voltage and a higher current. And what that means is that I'm able to drive the full load of the light through this, even though the Raspberry Pi itself cannot individually drive that. So realistically, that's all done. Some of it is 12 volts, so I have 12 volts feeding in. That's feeding this MOSFET, which is going to drive a 12 volt light. And then I actually have this very, very tiny little step-down voltage converter. So it's a switching voltage converter, but it will drive the 5 volt light as well as the Pico and the display. So let's go ahead and get into it. So I added the second LED definition here, but it's the same as the one that we were working with last time. And we still have the similar issue where when we hit it, it doesn't really work the way that we want it to. It crashes out. So with any luck also this time, it should be a bit better in terms of reconnecting. But the issue that I'm having now, so what I've gotten it to do is update the LCD screen successfully. Right? And you can't see that here because I just have whatever the last value was, which in this case is 23%. I'm just setting that manually through the duty cycle on the actual initialization command. I'll set that back to 0 just so it's the same. But we'll stop that, run it again. Oh, I didn't leave it long enough before I ran it again. And of course, the best part of this is because now that I have two input voltages, so I have the 12 volts coming in here, and then I have the 5 volts coming in through the actual USB connection to the computer, which will only be used for programming. I have to disconnect both in order for it to work. But in order to get the right, let me scale this, in order to get the correct boot sequence, I need to connect the external power first, let it finish booting, and it is successfully booting now, and then connect the USB, and then everything works fine. So if we actually look at it, we see that the white screen is showing up. It's connecting to Wi-Fi while it's showing there just because of the way that we have it ordered in terms of how it will actually do the boot sequence. And then once it does connect to Wi-Fi, it should load the screen, or at least it has been during my testing. Wait for it. It's going to be one of those things where it's going to make a mockery of me. Ba, ba, ba. Okay. Which is fine. You know what? Oh, I didn't reboot it. 1 second. All right, let's try that. All right, so that's booted up. Come over here. We'll stop this. See if we can get our script to run without. Yeah, perfect. Okay. So back over here, we can connect up our 12 volts, and it goes through the regulator, and the regulator is actually adjustable. So one of the things I had to do in order to make sure that it was going to be, or at least not going to blow up the Raspberry Pi Pico, was to adjust it to 5 volts before I connected it. And one of the ways that I connected it, just before we get into it, is I actually soldered all of the connections, and now that we got it up, let me disconnect it. I wanted to make it so it would still be able to come apart easily once it was inside the case. So I actually made all of the solder connections to the exposed pins that are on the actual headers in order to make it so this was pretty much stock. So if I had to replace it anytime in the future, or if I had to update the firmware and it wasn't in a convenient spot to be able to bring a computer to it, I could just remove it and bring it over to a computer. And I think that that makes things a lot easier in terms of trying to deal with it, especially when it's in potentially a very tight enclosure. Okay, so here's our code. Now we see the LEDs are off. And I have these two LED lights here. Sorry. The LED lights are off. And I have these two LED lights here in order to demonstrate and show exactly what is happening here. And I may need to get some clips really quick to stand these up. Trying to see if I have my solder hands in the vicinity. Let me grab those. All right, I don't have them here. So we'll just have to hold them as we go. But the USB connection that we see here is 5 volts, so this light represents that. So it doesn't go as bright because these are technically 12 volt LEDs. And then this connection is the 12 volt connection natively. So this LED will be very bright. And I think you'll be able to see that, or at least the effect once they're on. Let's do a quick test. So what I'm going to do is I'm going to set a value of 30,000 because this is a much higher resolution. It's actually base 16 instead of base 8, or 8 bits, I should say, instead of 16 bits instead of 8 bits. So that should actually make it a lot better in terms of trying to actually have some good resolution and also some good smoothness on the fading, which I think will make things a lot easier overall. So let's stop this. Let's go ahead and run it. And when we look at the overhead cam, we can see our LEDs are in fact on. And these are half brightness right now, but if I turn them off really quick by doing the same operation, we can see they turn off. And also the screen is updating accordingly. So there we see one's at 46% and the LED is on. Excuse me. So what we're going to do is we're going to go through this really quick and see exactly what we can do in terms of finishing it up. So I'll go back to 0, which is kind of where we were a second ago. And we were working with this function, which was fade LED last time around. And there are a few reasons I didn't like it. One of the reasons was that the global variables were not actually going through it effectively. And then also it wasn't saving the setting anywhere. So once you powered off the device, it assumed it was going back to 0, which meant it wouldn't resume after like a power outage or something like that to the previous value. And that was not one of the requirements that we actually set as far as what we actually wanted it to do. So I defined a new LED function, and this one's just from scratch. And what it is it's taking the target LED brightness from a file, and then it's going to set the current brightness to pretty much increment or decrement based on whether it's above or below the target. And the target is just a runtime value, so if it does restart, that would go away. But at least this way it preserves the current, or it preserves the current target. So yeah, it won't. Let me rephrase that. So if it does restart, the current brightness does go away, which means it will fade up when it does come back. But the target brightness will at least be preserved based on what it is. But it will increment and decrement the particular brightness based on whether it's above or below that particular value. So using that, it actually makes it so it's completely separate from any of the other function calls. So we were calling fade LED during the actual web call, which added about a second of delay based on the number of steps that it had to go through in order to be able to do that. So what I've done is I've actually split that out to an interrupt. And in this case, you see the initialization of the timer. And I'm using a one-shot instead of an interval, just because it makes it more interoperable between both Raspberry Pi Pico and the ESP32. And if you're not familiar with what an ESP32 is, I can show you a comparison here. So this is the Pi Pico, and this is an ESP32. And they effectively do the same thing. This actually is a bit more powerful, and the cost is not much more. But I just like using the Pi Pico just because it has it's very similar to the Arduino Nano in terms of form factor. It has quite a few accessories, things like that, like the LCD screen that we're using here. So I wouldn't necessarily use it in this application just because the LCD is form-fitted to this particular board. But if it was something where I wanted to apply this code to a different type of device or a different LCD screen, I might just replace the libraries and be able to apply everything else pretty much out of the box. So just to kind of show you where we are. So we have a fade timer initialized. It does it and it just runs the fader once. Okay, it is using this exception because the try up here is actually for the, it has an integer that specifies which timer it is for the ESP32. So ignore this up here, but the second line is actually what's doing the work. But it will give us a message saying that it's initialized. And if we look here, we see that it does in fact initialize. So all it's doing is printing. And then it will call the fade LED at some point, and that will also start the fade timer in the background, where it will continue to call itself. So pretty much every 10 milliseconds, which is the period, it's measured in milliseconds, it will run this particular thing, which is a similar delay to what we had. But the advantage of using an interrupt over having it just wait for the particular command to finish is that we can do other things in the meantime, like respond to web requests, changes, things of that nature. It will interrupt and pause whatever it's currently working on, and then be able to do this fade increment or decrement cycle, and then be able to resume whatever it was working on. So the interruption is very small, and we're trying to keep this as lightweight as possible because of that. Going through here, very few changes. Adapted some of it to be able to fill in some of the other values. Let's see. I should actually be up here with what I'm referencing. So it's supposed to fill in these values as the default value, and then be able to process that effectively as far as the web administration is concerned. The issue is it's not actually doing that. So if we delete this and just start fresh, we see it's not putting in a 0 by default. And if we inspect this particular page, and we go to here, we see it's not actually filling a value. So there's obviously an issue there that we need to actually rectify. So let's start there because I think it's going to make things a little bit easier. So we have the settings get LED1 and settings get LED2. And what this refers to is a function that I added related to the fade, where it will just pretty much open a file, since it is pretty much a general file system as it runs MicroPython. We can create files and write files just like we would with regular Python. So it will create it, and it will add the name based on that, based on what's actually put in here. So LED1, LED2, write that value, and then we can get it. And if it doesn't get it, it will initialize it with a 0 value. So if we actually tried to save this out to the Pi Pico, I gotta actually stop it first. So if we try and save a copy to the Pi Pico, we see that LED1 and LED2 do in fact have files here, but they're showing a 0 value. If we open it up, oh, I saved it. I apologize. So what I did is I just deleted it, that way it'll reinitialize it. If we open up LED2, for example, though, we see it's completely blank, which means we probably have a type format issue. So when we're actually trying to save it, we're trying to save an integer, where really we need a string, we need text. So in order to modify that, we're going to take this value and we're going to cast it to a string type value. So whatever that value is, we're going to make sure it's a string. Right, and we'll stop it and we'll run it. And it has completed. So I just closed out the LED2 because I want to reopen it. So I'm going to stop this here again, just because it should have initialized it to 0. Let me open it this time. And we see it doesn't look like it initialized it. Oh, I know why. Alright, so let's run this really quick. We actually have to do something. So I'm going to refresh this page. Alright, and we see LED1 has initialized successfully. LED2 still had a file there. So if we go back to Thony, and we open the file from the Pi Pico, assuming I stop it first, we now see that LED1 has 1 byte, LED2 has 0 bytes. So let's look at LED1, and we see that it has the 0 there, and it's the only text that's in there. Great. Okay, so it's doing something. Let's close out of that, and let's actually delete the other file as well. So we're deleting LED2, so that way it reinitializes. And let's run this. So it's trying to connect to web server. We're probably going to have to do a reset again. I wish I had a button that I built that I could just like press and have it actually stop trying to, or repower cycle it. But in this particular case, I don't have one because this is a special case in this scenario. Okay, we'll plug it back in. Plug in the external power. All right, it's booted up. All right, I'm going to hit the stop button. And run it. Now it's complete. We'll go over to our web page. I will refresh it. And we do see that now both LED1 and LED2 do have the values that we expect. So let's try setting 50 to LED1. All right, we already see there's an issue here. But it did save the value to the file. If we go back into Thony, we see it updates LCD screen, but in fact, I don't believe it did that. It says list index out of range, which to me says that there's potentially an issue with the interpretation into percentage. So, you know, it makes it a bit more complicated, but I think it's worth the effort because it's going to give us that granularity. So what we're doing is we're saving the current brightness. Let me actually scroll up to where that is, which is inside of our parsing script, the handle request for the particular brightness value. And the brightness is actually coming in as an integer, as a percentage. So we want it to be able to be human readable. So realistically, we have to convert that back to the regular integer. So what we do is we actually have to times that by 100. Or sorry, we have to divide that by 100 in order to get us a percentage. So if we type in 50, that should give us 0.5, and then times it by what is the max value for the pulse width modulation, which is the 65025. And then that's what it should save. And in this case, we're casting it to an int, and we saw that it was in fact saving. So it does look like this part is working successfully, which is good because I don't want to keep troubleshooting that. And then down here, we see it's updating the LCD. And everything's fine there. So the issue was when we read it back in order to fill this. So we actually need to take this, cast it to an integer. And what this is every time there's a %s, pretty much that means that we want to replace that particular string. Okay, so anywhere, and it goes in order. So because these are regular quotes at the end, we put a %sign, and then we can replace those values with an ordered list, which will fill in order one at a time, separated by commas. So right here, we're just reading from the file. And that's not necessarily what we want, because we want to be able to change it back into a %. So first, let's cast it to an integer. And I'm just going to do this kind of all at once. So we're going to divide it by our maximum value, which is the 65025. Right, we'll want to do all of that first before timesing it by 100, which will give us a percentage. And then we want to turn that into a static integer. So the reason we're doing integer is because it's going to be a floating point number by the time it comes out. And then we're going to want to cast that integer to a string. And that way it will fill in successfully. So we'll copy that over. because it is the same between the two. We'll save that out. We'll stop what's running. And something, it doesn't like something. And it may be we need to pre-process this as well. And I think we're missing that there. Right? So open, 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 open. So that's 4. Close is 3, 2, 1, 2, 3, 4. Three, 2, 1, 0. Perfect. Save that out. Run it. Now we see it's running successfully. And when we go back to our web page, without changing this value, which we set to 50, looks like it crashed. Let's see what it says. Alright, so it did error out. Let's see if we can run it again and interrupt that process. I do kind of wish they put a USB-C on the actual Pi Pico, just because it would be a little more resilient when it is plugging and unplugging. But that's just my opinion. We'll let that boot up fully. There it is, and now we'll plug in the other power. Anytime you create custom systems like this, it is a little bit finicky sometimes, especially when you haven't worked out the bugs or gotten it to where it's consistent in terms of its performance. So, you know, you gotta make sure you have a stomach for it, and if it does get to be too much, don't be afraid to step away from it and come back to it. So, you know, if they made it easy, it'd be it would definitely, I don't know that it would be as fun. So, let's see. We go back to the computer. Let's restart that script. I waited too long, so it's not going to do it. Do the same thing once more, but faster. Okay, binding complete. Plug in the other power as well. Okay. So at this point, let's go back over here. Let's delete what we have, just so that way it doesn't try and run it, which is causing the error. Did I catch it in time? Or did it just crash again? Oh, it did crash again. So what we can do is actually put this inside of a try response, a try exception. And what I've also added is some instances of this exception as E. And what that will do is what the exception that it throws will actually be stored to the E variable, and then we can just print it out to the debug console. And that will help with troubleshooting as well. So let's go ahead and implement that here. So we'll do try. We do need to tab just this one line. Because of the 3 quotes, it does multi-line, so the other stuff can all remain as it is. and then we'll do our exception as E, and leave the rest the same. So let's try running that. It's very cooperative for a little while. And we may actually need to deal with that, but we'll unplug this, do the same thing again, plug that back in. Oh, I know. And just so you know, anytime it's flashing by down here, where it keeps saying cannot find the COM port, etc., when it does reconnect to it, it's going to send an interrupt to cancel out whatever it's trying to do and go to the command line. Problem is that that can sometimes interrupt the connection to Wi-Fi, which can then cause it to hang. So what I'll do is I'll actually plug it back in, hit the stop button in order to get it back to just the command line, and then replug it, and then everything will work pretty much as expected. So just a weird behavior that's kind of annoying, but what can you do? So right now we're back at the command line. So now that we've put in our try and accept, let's go ahead and run it. So web server is now running. Let's reload this. Okay, and it says can't convert int object to string implicitly. So what it's complaining about is that we can't just convert straight from int to string. And that's fine. And we actually may not need the string cast at all in this particular scenario. So let's just delete that. I probably should have just left it out and let it call for it as it needed it. Let's see if we can run it again. No, it's going to be like that. So again, this is what I'm talking about, where when it starts flashing by, that means that it's not going to run. And if we try and hit stop right now, there's no COM port for it to actually stop and reset. So what I'll do is replug it back in. We see it goes back to here. I will hit stop once again, unplug it. See, now it goes to exit code 1, so just improper end of file. Then hit the stop button, and then we can run it as normal. So what we see here is it says it can't do that kind of conversion. And I think it's actually relating to us not converting back from our string to an int. So let's start there. Let's take this and change this to an integer. So casting the string to an integer. Do the same over here. That way when it does the math, and I'm just going to go ahead and reset this. And we'll run it. Right, and it did exit again. But this time it didn't give us an error, which means it's not exiting because of this. And I don't know that we can load it now. No, we can't. But it should load the actual code successfully. Let's just see if we can run it again, just for fun. Okay, so it did load. Let's go back over here, see if we can reload this. And we do see it says 49. So for some reason, it's actually going to 49.9999 So we may need to actually replace that with a with a rounding function, because it may be better to actually have it kind of assume that it's going to go to the closest integer opposed to just casting it to an integer outright, which would just chop off whatever was after the decimal point. So let's go ahead and just open a new tab and just verify that syntax. Bum, bum, bum. Okay, and this is micropython.org. Generally, they're pretty useful in terms of being able to to get it for you. Also, they're not a private organization. They are actually the nonprofit that proctors and moderates the actual updates and everything and releases of MicroPython. So since that's what we're using, I think it's just easiest to just try and use this. So let's see if we could do it. I don't know if it needs the math library to be added as well, but we can find out. Easiest way to find out is to actually go straight back to our interpreter, and we will type in the interpreter also, I don't know if you saw that, it shows up with the syntax there. So we'll have our number. So let's do 3.14, and then we'll do 0. And it does give us our 3.0. So I think that that is going to be a lot easier. But if you notice, it actually is still a floating point number. It just happens to be rounding it. So what we'll do up here is we will type round, give it our number, okay, which is this whole number here. Then we'll do comma, 0, and close. Same thing for the second one. And we'll save that out. Let's see if we could just run it. Okay, so now it's running. Let's go back to our page. And in this case, it can't convert int object to string implicitly. And my feeling is it may be because we don't have this declared as a string, which is what we removed earlier. And it gets a little bit messy in this regard. Because now we're doing a lot of type conversion. And this is one of the reasons why I like some agnostic programming languages like Python, etc., or excuse me, like PHP and Bash and things like that do the type conversion on the fly. But in a lot of ways, knowing what your actual data type is helpful to try and make it so you're actually inputting the right data. Because you don't know if it's actually going to be, valid data at the end of the day. If it's not actually going in properly, or if it's converting inappropriately. So, misinterpretations of the data, for example, if you want it to make sure it's always a number because you need to do math on it, you would have to do other checks in order to try and make sure that it is a number. Otherwise, it could give you some strange results. So having explicit type declaration, I do think has value. And programming languages like C, C++, all of those do have that type of functionality available. Let's see. Will it connect? Again, I had the rotating numbers at the bottom, so it didn't really initialize. It exited out as soon as it powered up. And this is what I'm talking about, where it never actually connects to Wi-Fi. So let's just do another reboot. See if I can abort this really quick. I can. Alright. Then we'll stop it there, and now we'll try and run it. Okay. And now it connects successfully. So that's how that goes. And it said the same exact thing. So it's not that. So we're going to clean up as we go. So we're going to try and just make it so everything's staying as simple as possible. Oh, and I have a feeling it may just be because we're putting these right next to each other without any additional modifications. And I think we might actually be missing a parentheses as well. So open, 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 open. So that's 4, 3, 2, 1, 2, 3, 4, 3, 2, 1, 0. So that one was actually incorrect if we look at the other side. So that could be part of the reason. So we'll try it both ways really quick. And it's parentheses and everything else, and the attention to detail has got to be pretty extreme, because at the end of the day, it's just going to do what you tell it. So if you tell it to do something because you put it in the wrong way, it's not going to work the way you expect. So definitely something to keep in mind is it can be frustrating, but usually there's a reason why it's happening. And again, it's trying to connect to web server. So we'll replug it. Stop it. And there we are. All right, let's see if we can get it to actually load. There it is. And we see it has the .0 at the end. So again, we don't want that. We just want it to be an integer. But, you know, we did get it to load with the correct value. So at least that's a step forward. So let's continue from here. So since we noticed that we had the parentheses issue earlier, let's try adding back in the int, which will chop off that trailing decimal. Hopefully by putting the parentheses in the right spot this time. All right, so we'll stop that, try and run it. Won't connect to web server. We'll stop it again, replug. Stop it, run it. Okay. Will it blend? So I'm going to refresh, and there it is. So now it's showing up the way that we want. We wanted it to show up without the decimal point, but still show the number as expected. And let's try this as well. So I'm going to set this also to 50. Actually, let's set it to 25 just so it's different. Hit set. We go back to Thony. We see there's no actual issues. It does say list index out of range. That's fine. All right, and it says it updated the LCD screen. But if we actually look at the LCD screen itself, it's kind of lying to us. So it's still showing 0%. So let's go ahead and fix that. So now that we've fixed the web interface, and even if we go here, we can run it again. The web server is still running. It's still doing things. So it hasn't fully crashed out. So I'm just going to stop this so hopefully we don't have to keep replugging it, because it's going to it's going to destroy the cable or the connector at some point. I know it, but, or at least it always feels that way. But so let's actually go down and find where it's updating the LCD. Right here. So update LCD with the LED values. So here's update LCD. And right here, it's getting the actual duty cycle. So it's showing a real-world reflection of what that update is. And that may not actually be what we want. It may be accurate enough, but it may not be what we want. But for now, let's leave that, because I think the actual issue is that we're not scheduling our fade LED. And the way that we're actually going to initialize that is just by calling it once when we start up, just before we actually get to starting our web server here at the bottom. So we'll update our LCD, and then we'll call fade LED. And because we have that recursive loop where it will automatically set its own fade timer to call itself again, it should actually be sufficient in order to be able to start it running. So let's see what we got. So it did throw an error when we did that. And it says 230 in module. The fade LED is where it was called. And then 178 we have in fade LED unsupported types for less than, int, and string. All right, so it's comparing two values that are, So we're comparing two values over here. So we added the fade LED, I'll just go back. So we added the fade LED here to the bottom. And the fade LED was calling this, and since it's recursive, since it calls itself after 10 milliseconds, it will actually do the fading from there and continue to run while we start the web server and everything else. And the actual error that we received was unsupported types for less than. So LT is less than, and GT is greater than. And it's saying int and string. So you can't compare an int and a string because, again, it doesn't know how to do it. So we need to specifically cast the number that we pull back out to an integer. So we'll do the integer type declaration. And the main reason why we have to do this is because since we're storing it to a file, it's a text file, so it can only contain text. It doesn't know what type it is outside of being strings, or at least strings of characters or character arrays. So it's something that we have to explicitly tell it, no, this is a number, it's okay. We know what we're doing with this. All right, so now it's bound to the web server. We didn't get an error, but we also didn't get a change in the value. So if we go back to our overhead cam, we see it's still showing 0 down here. So it's still not working as expected, but we do believe that it's running. And a way that we can confirm that it is running is by adding a debug command every time it runs, which is going to be a lot of them. But let's go ahead and do that. And I think it's pretty safe to say it is, but let's find out. See if we can run it without restarting. And we see fade LED is definitely running. Okay. It's still running because we haven't actually stopped anything. And that's the big issue with interrupts, is that if you're going to actually do a call to remove it, it won't actually get rid of it. So I will show you there's a way to actually remove those types of interrupts. And one of them is by clearing this out using a finally. So in the same way that we use try except, we can actually add another term which is finally. So if the script is exiting, we can have it deinitialize a lot of these values. And maybe we should actually just go ahead and do that. Otherwise this will keep building up and we'll keep having to reboot it. And I'll show you an example here. I have a number of try and accept commands, but then at the very bottom of the script, because I want it to exit cleanly, I will actually have it close a number of these particular commands in order to make sure that it's not continuing to run. And this is part of the way that I was actually able to get the web services to exit cleanly, is by propagating keyboard interrupts. So if I received an exception that was a keyboard interrupt, I would raise it, and then I would pass that along, and that would actually cause the web server to exit cleanly without having to plug and unplug it every time. But again, it gets kind of messy in terms of putting a lot of stuff in the code that would actually make it do it. But one step at a time. Let's just start with this next part, which is just doing the finally to make it so it stops running. And the way that we're going to do that is by actually having it set a value. Let's call it, we'll call it exit now. Right, and we'll say false, and we'll just have it so if it doesn't do it, or if exit now is not set to false, if exit now is set to false, then we will run the code. Otherwise, we will skip it, and that will keep it from calling recursively. And the reason that we're doing it backwards like that is just because it makes it read a lot more like plain English. So if it's not exit now, then we'll exit now. So that's why we set it to false, and when we actually do the finally at the bottom, then we should have something here. So let's see what we could do with this. Will it blend? I do need to reboot it though, because it is still continuing to just regurgitate tons of fade now. Once more. Let's see. Yeah, I don't think it did it properly. Let's see. Okay. There we go. So I believe we still have this set. And it set this to 25 for some reason. And now 0. Let's see. That was definitely interesting behavior, because we didn't have that before where it was actually reducing its own values on its own. But let's see if we can get it to stop here. And just to keep everything consistent, let's just verify first that we're actually getting our fade LED to stop running. Alright, now when we stop, okay, so it is actually stopping it when it's running. So we do see that it's working, and it still presents an error, things like that. Gets a little unhappy because it's doing something in the middle. But that's perfectly fine, you know, as long as it comes around. If it takes an extra second, that's not really the end of the game, because that's not our runtime condition. That's just our debugging condition. So, you know, no harm, no foul. But now we need to find out exactly what we're trying to do with this in terms of how we're going to debug, making sure that the percentages display correctly. I'm not going to worry about the issue that we just saw in terms of the decrementing of the actual values on the web page, just because I think that will probably work itself out. So. So right now we're taking our target brightness from LED1 from our saved file. Same thing for LED2. Our current brightness is based on what the current value is set as a 16-bit integer representation. And if the current brightness of the LED is less than the target brightness, it's going to add 1 and then set that as the new duty cycle. And if the current brightness is greater than the target brightness, it's going to subtract 1. And it'll do the same for both LEDs. And we're not receiving an error. And it's also not exiting, but it could be because we don't actually have any kind of verbose output, and because it's in an interrupt, it's not going to stop the execution of the script the same way that everything else will. So let's add a try and except with our verbose output. Well, I'll just type it. So we'll tab that forward to fit into the accept. Keyword is exception. You see it turns blue and highlights as E. And again, E means, when it goes italics, by the way, variables in particular, it means they do actually have a value. And that goes both when you're reading them as well as writing to them. So it's just a little validation indication through the fonting. And then we just do print E. Save that out. We'll try and run it. Bind to web server complete. Let's go over to our web server, refresh this, see if it's doing what we expect. Now we see that it's there, but we don't see any errors coming up, and we also don't see any kind of action or activity on the LCD screen. That being said, the LEDs are not doing anything either, if we look. So our LEDs are still off. Right, we do have our power connected, and there is actually a confidence LED on the individual NMOS or MOSFET drivers as well. So we know that there's actually no output indicating that they should be turned on. So something is not happy here. And it could be our LED specification. But realistically, because of the way that Python handles global variables, these should be able to pass through just fine. So we're not actually declaring them in this scope. We're declaring them in a higher scope up here where we say what LED1 and LED2 means, and then we're not overwriting it. So there's no reason why it should not be able to update this successfully. But just to make sure, let's stop the script and let's work with the command line for a second. And let's actually let's go through this one command at a time and just paste it in manually. We have to define it. All right, so now we defined it. We defined what that function is. So now we can go over here. Now it doesn't throw an error. And we have to define LED because LED is not there. So let's define all of this. I'm just going to copy all of it. Just because I think it's going to be a little bit easier. All right. And the reason it's saying import pin is not defined is because we haven't imported the machine pin. So we're going to do import machine, and actually I'll scroll up to the top. But that's what we have here. So it's actually from machine, excuse me. So from machine, import pin. All right, and then we can actually paste in these values that we have here. And PWM is not defined, so we'll actually do from machine import PWM. Let's just do the same thing again. And now we see it complete successfully. So realistically, as far as the import procedures, everything else like that, it's just bringing in additional libraries to be able to know how to interface with the hardware successfully. So now we have LED1 and LED2 defined, but we're only going to worry about LED1 for the time being. So we should be able to get the current value of the LED. So if we print this, we see that it currently says the current value is 1. Okay, excellent. So we can also, because earlier we got our target brightness LED1, we can print that as well. And we see our target is 32,512. So let's run this if statement and then revisit it and see where it got to. So I'm going to copy this, I'm going to paste this, let's see if it runs successfully. And the reason it doesn't like it is because of the indent. Let's see if we can fix that first. So we do have to repaste it. I don't think it will care about these being extra indents, but let's find out. Okay, so it did it. And now we can print the current LED value again, well, we can actually retrieve it and get the current LED value. And we see it's 2, so it is actually doing something. So let's actually set this up in a while loop. So we'll do while current brightness is less than target brightness. Right, which is effectively what the fade LED is doing. It does get to a point where when it is the same, it will actually, stop doing anything. It will continue to run, it just won't do anything. But that's fine. We just want it to keep going, that way it watches for changes. And it doesn't cost us anything in terms of real processing time, because if there's nothing to do, it doesn't really take up any cycles. So we'll copy this. Ooh, excuse me. We will tab that in there. The rest of the tabs should be fine. Then we're going to have it update the current brightness. So it's doing this if statement to increment or decrement the particular value. It's going to set it, and then it's going to update the current value for the next run. So let's see what it does. All right, it's running, it's running. I should have added a print statement in there so it looked more visually appealing. All right, I'm going to actually interrupt it, and let's just see where it got to. Right, and it's currently at 160, so it could just be that it's going incredibly slow. So let's do the same thing again, and I just hit the up arrow. I'm going to add a print command here, so that way we can see what it's currently at. But let's add +10. And the issue with this, of course, is it's going to overshoot it, and then it's going to keep oscillating around it. So it could cause flickering in the lighting that's undesirable. But for testing purposes, I think that's perfectly fine. But it should go faster. All right, and if we look here, we see the light is actually turning on. Right? So now if we set our target well, that's annoying. If we set our target arbitrarily, because we're not working with the text file right now, it's not updating from it. But if we set that to 0, and we rerun this, but we actually change it to where we're going the other direction, right? So current brightness is greater than, then we should actually see it start to dim. All right, and I'm going to set this back to, let's set it to 5, just so it goes a little bit slower so I have a chance to actually switch cameras here while this is happening. So, did it reset? By the way, this is the challenge of doing live streams for technical projects, is that we're trying to show it in real time, but realistically, it doesn't always cooperate. So, all right, so I set it to 5, so it's going to decrement by 5 as we're going, and I reverse the less than symbol to greater than, and now we'll run it. Right, we see it. I'm going to switch to the overhead. We see it has turned off, although it is still running. So I have a feeling that our console is not keeping up with our particular run. So I'm just going to hit the up arrow again. We will set this to max brightness. So 65025. I'll have it go by increments of 1, which is what we have in the script currently. And change that back to less than. All right, let's see what it does. Oh. Now let's see what it does. If you look, it actually looks like it got stuck. And I don't know if you could see this. There's a little wisp of light there. So something got very unhappy. And it may be that we're trying to update it too quickly. And I had to force out of it. So what we can do is add a delay. So we will, and actually I know we're going to have to import sleep, or import time to get to a sleep command. So we're going to do time.sleep, and we're going to do 0.01, which is what we're currently doing by running the script every 10 milliseconds. So now it should actually delay. And let's see if that helps the performance. Oh, that's annoying. So we have to redefine this. Oofed. So I'm going to redo the declarations. We'll re-import the pins. We will reinitialize at least the first value. And then we should be able to run the loop. All right, and this includes our sleep command. On target brightness, we have to redefine as well. That we did set manually, though, just so we can keep everything simple. All right, and 65025 is the maximum. Right, it looks like it's stopping at 160, despite this. At least this time, it did respond to a keyboard interrupt, so I don't have to reset everything again. But let's see what's kind of going on. So if we change this to +2, what do we get? Well, I like Thony a lot. It does have a bit of a clunky interface in terms of having some aspects that are like the command line, where I can hit the up and down arrows to be able to go through and recall, previous commands. But if you overshoot on the up and down arrows, it will just blow it out, and then instead of preserving what the changes you made were, it will just restore back to the history. So that's why you keep seeing me have to re-edit things. Right, now we see it's working, and if we actually look at the overhead cam, we can see this LED start to come on. And if we look here on the actual driver, we see the LED starting to come on there as well. And it's going pretty slow, but it is doing it. And that's with the 10 millisecond delay. So my feeling is that that's a little bit too slow. I think the 10 millisecond was actually significantly better. Maybe 5 is appropriate. But we do see that it's actually doing something. But we do see that incrementing by 1 at a time did not work. It got stuck. So obviously we don't want that. So let me Control-C out of this. Let's see what a more reasonable value is. So let's go back to 10. And 10 is what we did before, but it just kind of blew it out of the water. Right, so just recalled it, edited it to 10. I'm going to run it right now. Let's watch the LED. Right, and it's still taking a second. So maybe even 10 is not enough. Again, counting to 65,000 is quite a bit. So I'm going to go back over here. We'll edit this. Let's make it 100. If we're going to do this, let's see. Right. And there we go. It actually finished. So this is full brightness. And we'll do the same thing by having it go down to 0. So I will copy this up here. We'll set this to 0. We'll rerun the exact same script with the modification of changing it to greater than. Right, so no change down here. Everything is pretty much the same, just change the condition for the loop. We go back here, and now we should be able to watch it fade off. So what happened there? It did it 3 times. And the key thing was, if we actually look at the computer and we go over to here, it had to synchronize with a number that was divisible by 10. So it did it multiple times because it had to overflow. Let's see if we could find the transition point. Right, so there's obviously a mathematical issue associated with it. It may not be a true 16-bit number. It may be simulated. So we see it goes up to here and overflows and wraps around. Because again, it's actually looking at the maximum value there. We're not setting it to the maximum value, it's just close to the maximum value, just so it keeps the pulse width modulation aspect. But otherwise it would just be on, which may be something that we want, but we can reevaluate that. So as far as this is concerned, it's wrapping around because we're taking off too big of a chunk and we're not actually kind of scaling it back as we get closer. So just something to keep in mind. So we would have to set up additional conditionals in order to be able to make it so it would kind of ease in and flatten out and hit its mark, opposed to overshooting it. So what we can do with that is we could just add in, if I'm just going to copy it from up there. So since this is less than, if the target brightness minus the current brightness is less than 100, don't do current brightness, just set it to the target brightness. Otherwise, we'll do this with the 100. And this is going to be the exact same thing for LED 2. So I'm going to go ahead and copy and paste it. And actually, I noticed a minor oversight, but that's fine. It's going to get corrected with this. If you see here, I set this on LED 1 for which LED it's actually updating. So that could have caused some issues. But going from here, we want to do the same if else, but with the other direction. So we'll change this to minus. Still less than 100 because we have the order reversed. And actually, it's the same outcome. And this will be 100 as well. As we saw, the steps in 100 actually went quite quick. Right, and looking through here, it does look like we got all of that set. All right, so we can hit the stop button, and let's try and run it. All right, so both LEDs are now on. All right. So if we come back over here, we see that it looks like one of them is set to 50, one of them is set to 25. So I'm going to set LED 1 to 100. Let's watch it. Okay. And our LCD screen is not really updating at the right time. It's updating right after we make the change, but that doesn't necessarily reflect what it's going, what it's currently doing. So we may want to have that do something a little bit different. Also, it's flashing every time it updates, which is kind of annoying. We need to come up with a way to make sure that it's a bit smoother. And I think I have a way to do that. But we see that it is working. And if I go to brightness and I set LED 1 to 0, We see it is fading off. Will it go out? It went out. Right, and LED 2. If we hit set, and we see that that fades off too. And the 12 volt LED obviously is going to be a bit easier to see. So let's set it to 100 and watch it fade up. There it is. We can set it to 0. Excellent. So it is kind of doing what we want. And we can actually set those values arbitrarily to be able to take whatever step size that we want, because I think that's even a bit too slow. So maybe 100 is not aggressive enough. So let's say we made it 200. Right? And the nice thing about the way that we have it set up now is it really doesn't matter, and we can actually define that as a variable. So let's do step size equals 200. And then we're going to replace all of these integers that we have defined repetitively here with this variable, which will make it a lot easier to update in the future, since then we can choose kind of what our rate is, what the angle of our fade rate is. Okay, and we can stop this. Let's try and run it. It's going to do this because of course it is. I'm going to have to plug it, stop it, and then unplug it and plug it again because reasons. Whoop. We'll do it, or will I have to do it a third time because I missed it? Okay, good. Let me actually do something really quick because I think this will be easier. And I said I was going to do this last time, but obviously I did not. Okay, so now we can see everything all in one. I'll even see about... There we go. So let's try and make this more, or let's test it first. So we just changed the value to 200. So this is LED 1 right here. So we'll hit set. And we see it fading up. Again, the LED screen is not actually updating, but that's okay. And we can make it 0. And simultaneously, we can set this to 100. And we'll see that one will fade up while the other one's fading down. That's part of the value of having the interrupt call opposed to having it set where it would freeze as an action was being performed. We don't want it to do that. We want to be able to make the changes as we want to. So it's going to be able to do multiple actions simultaneously because they're not conflicting with each other. So let's go back into Thony. Let's take a look at some of the other things that we could do. So first thing, for your sake, I actually want to change the display so it's bigger, and then also correct it so that way it looks a little bit better. So last time around when we were experimenting, we did notice that this was the height. I think we have a little bit more real estate to play with here, considering we only have two variables that we're showing. So let's go ahead and just make it 60. We'll keep the first one as 20. We'll make the next one 60. Right, so instead of 40, this is going to be 80. And also, I did figure out exactly what this particular number right here, this is the bottom left-hand corner of the text. Because the text has upper and lowercase letters, you can't always rely upon it to actually have, you know, something at the top left, like most other things, to be able to guide, you know, create that coordinate plane. So this is actually the lower number, and it creates a 2-pixel offset on the bottom, and this is the offset at the beginning, so of the origin of the bottom left-hand corner. So that's what those numbers mean. So this will still start, this will start at 58. I'm sorry, 68. Wait a second. So it started at 28. We're adding 40 to that. So it is 78. We're adding 50 to that. Whatever number we're adding to it, it was 2 pixels less than the next transition, which is 80. Wonderful. Math is great. So this one is technically 80 plus 60, which is 140. So we're going to do 138. Let's try it. Maybe it looks terrible. Oh, and it definitely does. I think we went too big. So instead of 20, let's just try 30. Because we see it's overflowing the screen. And I don't remember exactly what the actual vertical resolution of this particular monitor is. But 38, 48, 58, 68. And that may still be wrong. Alright, does look a little bit better. Let's try 40. Alright, that doesn't look terrible. Text size is way too small. I'm not sure if there's a way that we can change that. But there is a way that we can look at it. So let's actually ask ChatGPT. I wasn't specific, I just said text on the screen. It assumed I meant the web page because that was the last thing that we were talking about. So how would I make the text on the LCD screen on the Pi Pico bigger? Right, so it says it has a built-in library. You should use that. If it doesn't, you might need a different library. Excellent, that's wonderful. Okay, so it did give us at least its interpretation of what would be the way to do that. It's still going, though. It's giving us a lot of information. And that's part of the things I like about ChatGPT is it's very thorough in its explanation. If you go to some of the other AI models, they're not as thorough, or they still require you to do a lot of searching for yourself. Where even if, I mean, you have to take it with a very big grain of salt that it may not be accurate at all. But it is certainly something that is useful in terms of just trying to get that baseline. So let's go back into Thony, and just before here, so we're going to keep the IP address size the same. Let's add this in, see if it does anything, because it may work, it may not. We'll have to find out. And it does not. And if we actually look at our library, the height is 128. That's what it is. But we're not necessarily seeing anything in particular that will let us know that there is a way for us to do that. Okay, which is fine. But maybe frame buffer does. So we can ask, so in this particular case, it's actually telling us to create our own JPEG and then fill the screen with that. That's really what it's saying. Right, so it's doing each pixel individually and doubling it. Or at least scaling it accordingly. So that may not be what we want, but that's fine. So we'll skip that part for now. As much as I would like to show you, I don't have anything that'll zoom in closer besides the microscope, and I think that's just going to be too close. Or at least we're not going to be able to see the LEDs. We could try that. Let's see. Will it blend? going to make me do a... maybe. That might be a bit much. Let's see. Let's try it. Can I make it so it doesn't? Maybe. Let's see. Good enough. All right, so at least that'll get us started so we can see the percentage symbols. Sorry about the moire effect. Again, only so much I could do about that. That's a little bit better. Yeah, I think that's about where we're at. So I'm going to try and not knock all of the stuff down as I'm going. All right, so continuing on from there. So what I've done is I've just reverted the code pretty much back to where it was before. And what we're going to do is try and make it so it updates accordingly as everything starts to actually run. So what we're doing right now is when we actually save a new value through the web page, right, like 100, it will update, but it will only update to the value at the time of the actual LED as it was set. We don't see it climb up and increment. That way we know when it's actually done. So what we want to do is definitely have it go through and update it more incrementally. But what we were seeing is every time it updates, just like that, so I'll hit set again, we see it does flash. And I don't particularly like that. I think that's not really a good look for it. And I think part of it is because we're doing the LCD fill and putting white as the background. And we do the LCD show here first, which shows a blank white screen, which is kind of what we're seeing in the flash. And then we're seeing the LCD show down here, which is actually applying everything else. I think there's entirely a possibility that it will layer successfully and update all at once, which could eliminate that flicker. So let's try commenting this out and see what kind of performance we get. And this is the critical flaw because it's going to try to connect. So let's see what we could do. So I'll stop it. Power cycle. Right, plug it back in. And it went with the version of code that we most recently saved to it for startup. Right, so now I just ran it from what our current working code is. So now let's see what happens when we hit set. And we see there's no flicker. And it updates pretty quickly. So something that's interesting is we may actually be able to have it update in real time with the fade function, opposed to calling it independently or calling it when the web browser is updated. So I've changed around this function since the last time as well, where in order to get the IP address, I have it calling WLAN. But so that may present some issues in terms of adding delay to the actual interrupt function. But LED1, LED2 may not be needed because we have those in the global scope. And LCD may also not be needed because we have those in the global scope. So I'm actually going to comment out this particular line and redefine this. And pretty much I'm going to get rid of everything. So that way there's no calls, or there's nothing that's required for it to be able to run. And we'll just try that, see how it goes. We may need to go back to this and actually just define it and copy and paste it. So let's add this just before, when we're doing our fade, just before our timer. Now that it's no longer flickering. And we'll do a quick search. And what I'm going to do is I'm going to comment out the other instances. Perfect. So we just had those two. So now the only time it's actually going to update the LCD is when this function is running. Now, granted, because this is an interrupt, we want to keep it as short and simple as possible. Otherwise, it will consume all of the amount of processing time that it has in order to be able to do this. But let's see if we can make that work. So I'm going to stop this. Let's see if we can do it without having to replug it again. And in this case, because that was the only thing running, we have to comment out these other lines as well. Let's try that. Right, and we actually see that it's now incrementing with the LED. So as the LED starts to brighten, so does this. And in this case, that's only the 5-volt one. Oh. Let me see if I can give myself a bit of a better runway here without chopping my head off. Or without moving this. Alright, so we see our debug commands are actually getting in the way. But it is working. It is doing something. So let's quickly comment those out. That way we can see what else is going on. Whoop. Excellent. So now let's go over here and let's set LED 1 to 50%. Didn't quite make it. Now granted, we don't have the same smoothing that we have here for our percentage. So that's something we'll have to keep in mind as well. Is that something that we need to reevaluate? And we can set this to 50. We can set this to 100. And we see it's doing exactly what we're kind of expecting of it. Where it's going through, it's actually changing the values as we expect, it's displaying that, and it's also activating the LEDs for the output. So we're getting really close. So let's apply the same smoothing that we did for this, for our web page. Helps if I put the value that we're rounding to. All right, we'll stop this. And we will start it. We're getting the implicit string error. Right, we see that here. So let's try this. I can't see a significant amount of movement here. But we still get the error which says can't convert int to string implicitly. So let's see. Ah, okay. So we had the parentheses in the wrong place. Let's try it as it sits right now. I don't think it needs the string declaration because there was a different error. But let's see what it does. Okay, we see the numbers are climbing. We see the percentages are also climbing. And they reach their target, and they're showing the correct integer values to match what we're currently seeing in the web page. So if we set this to 75, we do see one of them is starting to dim. If we set this one to 0, we see the other one also is acting appropriately. So it looks like it's working at this point, at least enough to satisfy what I'm looking at. And what this is going to be is that I'm going to save this out, and let's put it in the enclosure. And pretty much that'll be it for tonight. So there may be a few other tweaks and things like that that I'll do. But what I'll do is I will actually post this code to a GitHub, so if you wanted to actually download it in the future and try it for yourself with the code that we worked on this live stream, you'd be able to do that, and that I think will at least give you a good head start in terms of experimenting it. I'll also put a list of the devices that I used, just so if you want to replicate it, again, you could totally do that. So let's go ahead and save this out. And now what I'm going to do is I'm going to unplug the USB connection. Okay. And I'm going to unplug power, unplug the right power cable. All right. And let's try and use it without it being connected to the computer. So first it's going to connect to Wi-Fi, then it should start. And here we see LED 1 starting to turn on. We can turn on the second one. Perfect. So let's go ahead and finish the assembly. So I'll unplug this really quick. Let's go to our overhead cam. I'll push the keyboard out of the way. And what I have is this box, and it had the silver line last time I showed it, but I since cut that out and filed it down a little bit in order to make it so it would fit this LCD screen very nicely. And what I'm going to do is fit all of this into this tiny little box. Actually, and just so you know, this whole time the screen tab has been a screen protector, so that way I can mess around with it without it getting damaged. Right, so it fits in like that. And what we're going to do is just put a little bit of hot glue in order to hold it together. Alright, and pretty much this is going to fit in here. There's going to be a driver on each side with the cable coming out. The regulator will likely go on the other side. So I may want to do that before I glue it down. So it kind of curves around like this. And then the remainder of the cables just tuck around, and the 3 cables come out the other side on the through these notches that I put right here. And I made these notches such that they can actually grip the cable a little bit, or at least the USB cable. And of course this hot glue is pretty old. As is the glue gun, so let's give it a second to heat up. So, but now you really see why it made sense to attach everything to the LCD screen, because the LCD screen is going to be permanently mounted inside the box. The only thing that's going to be visible is the screen itself, and then it still allows access to the Pi Pico to be able to perform the updates if there's a newer version of the software that we want to try and deploy to be able to make it, better. If we want to change the rate, for example, that it goes, or if we want to add a potentiometer to be able to adjust that rate on the fly, we could do that and then update the code or do whatever that we need to do in order to make that adjustment. All right, it is getting there. And just for the record, with this particular type of live stream, the reason why I do it this way is because I would normally be doing this on my own anyway, so I figured I might as well share it with everybody. So hopefully, if you do like this kind of thing, please hit that thumbs up button and be sure to subscribe. All right. So what I'm doing is just putting a glob of solder at 4 points. And the reason I'm using hot glue is because it doesn't actually get that hot. so it doesn't damage the components, but it's also removable. So if something goes wrong, let's say the LCD screen decides to crack, you know, it's something where I can remove it and potentially replace it. Also, it's non-conductive. But it does kind of make a mess. Hopefully that doesn't interfere with the box closing. And another option for mounting this would also be using bolts. A lot of these have holes that we can actually put like M2.5, M3 bolts through. But in this particular case, it's just, sometimes it's easier to just go with the simplest solution because, you know, it's not necessarily something that's going to have a lot of strain on it or a lot of, you know, a lot of concerns for that type of rigidity. If you're going to put this in a vehicle, for example, you may want to do it a little bit differently and harden it a little bit more. But in my case, this is just going to be permanently mounted somewhere. But in the interest of brevity, I'm going to keep it to that. I will see if I can close this up. Let's see. So it's pushing up on this a little bit. I'm actually going to readjust it at a later point, but right, so we see it there. Just got these two wires hanging out on one side, one for power input, one for power output, and then a USB connection. All right, let me get the hot glue gun out of here really quick. And now we have the big reveal. So this is the big reveal. This is what this whole thing was for. Is these LED lights. So it's this signage. I have another one that's of an astronaut, but it's bigger. I don't think I'll be able to fit it into frame. But let's plug this in. It'll connect through Wi-Fi, which will have no problem going through the box. I'm actually going to remove the plastic. Get that nice peel action going. All right. We'll plug that in. Hopefully it's the right way around. It's probably upside down. It is. Now it says it's on. Assuming we didn't just kill it with the hot glue, because that would be really funny. Oh, it does look like it is on. And I did test this earlier, before we started with all this. Well, let's see. It says it is on. Let's check the voltage. Make sure I didn't fry it. That would be the ultimate in making it really annoying. I don't have a test point on there. Luckily, I have protection on the probes. All right, it says -5 volts. Okay. So the voltage is there. Let's plug it into a different source really quick. No, it's not powering up at all. Wait a minute. It's a manufacturing defect. That's fun. One minute. Alright, so it's not actually something we did with this project that broke it. I'm not sure how this is held together. So if you see that, it's the button. So, but let's put this back together really quick because it's not what we were doing. And then from there, we can plug it in. I'll finagle the wire and fix it later. It's supposed to be a nice reveal. Oh, no, it's not going to do it. This is going to work. We're doing this. I need bigger pliers. Boom, boom, boom. Actually, I could bring in the other thing. I feel like I'm going to have to take a Dremel to that. Alright, and this is our little spaceman here. And this one does have an integrated controller, which I have to bypass. And I wasn't planning on using this one, so I didn't have it ready to go. But I do have the parts here to do so. So I'm just going to clip this off and just put a straight connection right on it. Oh, there it is. So I stripped the wire, just using these little fast-on connections instead of soldering on one. Just for speed, and honestly, for power connections, they're actually a little bit better. Alright, and it's either going to work, or it's not going to work because I have it backwards. So this one's going to work. Alright, right now we have it set to 50%. Let's set it to 100%. And it's going to be tough to say because, I mean, realistically, it's not even at 100% yet. It's just going to dim the screen. So if you use this point as the reference, you'll see the camera iris closed as it's actually going there. Then we can bring it to 0, and let's watch it fade. Right, and you can see the percentage a little bit. I don't know how big of a screen you're watching this on, but I'll kind of read it off. So it's at 30% right now. Screen's getting a little bit brighter. 20, 10, and 0. So right at the very end, you saw a little bit of flickering. You know, that's not unusual. It's very difficult for that last portion of the curve to actually get it to go very smoothly. Because the difference between being on very, very little and being off entirely is significant. So generally, it's something where you could smooth that out by putting in like a logarithmic curve, so it gets softer as it goes towards the lower end and moves faster as it's brighter, since that you can't really notice. You can't really notice the difference between 99 and 100%, but like this is 1%. And you notice how it just turned on. So, but this is a lot of adjustability to be able to really put in, a good amount of control over something that you wouldn't necessarily otherwise have it. In this case, we have a web-based control, but there's no reason why we can't take the URL, and be able to integrate it into something like a Stream Deck, because it does have the capability to be able to do it with push button settings, so we could have it turn it on, turn it off, and have it do a nice fade in the middle. The only other thing that we didn't actually satisfy as a function of the original, I would say, prospect for this particular project is the ability to turn it on and off while still maintaining a particular brightness setting. And I'm okay with that. I think just setting the value between 0 and 100 right now is just fine. And if I was going to integrate it with a Stream Deck or something else like that, I would never even notice the difference. But if I'm going to actually have it act like a light switch, where I want the web page to actually do the bulk of the work, I'm definitely going to want to have that type of functionality. So I will add that before I upload that to the GitHub. Upload this to the GitHub. So I'm going to stop playing with it now. Fine. So thanks for watching the video today. I know this has been a real long one, this, video, the live stream. But if you're watching this after the fact, it is going to be a VOD. But thank you again. And if you like the video, be sure to hit that like button. Leave a comment down below and refer a friend, tell a friend about it. And if you haven't subscribed to it, please subscribe. It definitely helps out a lot. And be sure to hit that notification bell. That way you know the next time we're getting extended. So until then, take care.